Hello, chemistry fans, and welcome back to Chemistry Problem Solving Session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'm here to lead you through these problems. So let's start real quick. All right, consider the following amino acid. Circle the R group. Is this amino acid polar or non-polar? Ooh, amino acids. Well, let's talk about amino acids first. It's our first question about them. Let's get a little bit of information. Amino acids. You've all heard of them. Probably most of you have taken supplements of them. They're very important in our health. You have to have them to be healthy. They help build proteins and things like enzymes and stuff of that nature. But where does the name come from? Amino acid. Remember back in chapter 11, I insisted you memorize the class of compounds? If you were successful in doing that, you could probably figure that out on your own. This group right here is known as an amine. And this group right here is a carboxylic acid. So that's where the name comes from. Amine becomes amino and acid from the carboxylic acids. So it's an amino acid. This carbon is known as the alpha carbon. It is the carbon sandwiched between the amine and the carboxylic acid. Every amino acid that occurs naturally has that alpha carbon right between the nitrogen and the carbonyl. It's always there. There's always one hydrogen on that carbon. Always. Naturally occurring amino acids, there's always a hydrogen on that carbon. So the nitrogen, carbon, carboxylic acid, the alpha carbon always has one hydrogen. Always, always, always. Where it differs is the non-hydrogen group on the alpha carbon. It could, now I said the non-hydrogen group, it could be hydrogen. There is an amino acid called glycine that has two hydrogens on the alpha carbon. This is not glycine, this is an amino acid valine. Notice this group right here. This is the R group. The R group is the group coming off of the alpha carbon that is not the hydrogen. So I circled the R group. Is this amino acid polar or non-polar? It's non-polar. And now how do I know that? The R group contains only carbon and hydrogen. So that must be non-polar. Just like a saturated fat or unsaturated fat, that's the non-polar side of the fatty acid, for example. This is non-polar. And for the most part, now it's not 100% true, but for the most part, anytime you have a side chain or an R group that contains only carbon and hydrogen, no oxygens, no nitrogens, it is non-polar. There are two examples two exceptions to that rule, but don't worry too much about those. Just worry about if it's carbon and hydrogen in the R group, it is non-polar. There are two exceptions you don't have to worry about. All right, so that's how it's done. Now I hope that was a little bit informative in introducing you to amino acids and what they look like and how they must be. And I hope that it's become very clear to you how this is. Be able to identify the R group, to circle it, and be able to identify it as polar or non-polar. Okay? Now with that, I'd like to wish you good luck and good chemistry.